Do you know as to where are these loads being transferred? These are transmitted to the soil on which these structures rest upon. Soil, to a civil engineer, is a medium which bears the load of engineering structures. Soil is also used as construction material in embankments, earth dams, etc. The foundation of a structure is a medium through which its load is transferred to the underlying soil. For safe and economic design of foundation, it is necessary to determine engineering properties of soil. These properties, such as shear strength, permeability, compressibility, etc., control their behavior or performance as a material. Samples are obtained from different depths and locations to incorporate the variations in the nature of soil. The depth of exploration depends on the type of proposed structure, its size and weight, soil profile, and its physical properties. In general, the exploration should be carried to a depth which includes all strata likely to undergo undesirable settlement or shear failure due to structural loading. Samples should be collected from the influence zone, which extends up to a depth of 1.5 times the width of foundation. For compact building sites, say up to an extent of 4,000 square meters or so, samples are collected by making boreholes, one in each corner and one at the center. For small buildings, a single borehole at the center is sufficient. For carrying out soil exploration for road construction work, the samples should normally be collected at 100 meters apart and up to depth of 1 meter. The spacing may be increased up to 500 meters for uniform ground and soil conditions. In case of pile foundation, the samples are collected up to a depth of 10 to 30 meters. For preliminary survey of a dam site, about 4 to 5 borings perpendicular to the direction of water movement are executed. Depending upon the nature of soil and degree of disturbance permissible during sampling operation, soil samples can be classified as disturbed and undisturbed samples. Look at this palace of cards. These are at present in undisturbed state. Such a state of the soil structure may look like as shown. However, when subjected to certain disturbances, the original soil structure is no longer maintained. Undisturbed samples are obtained to assess shear strength, consolidation properties, or in situ permeability of the soil. Disturbed samples are enough where soil is to be used for construction purpose or when exact determination of properties is not required. They are also used for soil classification, moisture content determination, or to obtain compaction characteristics. To collect samples from desired depth, access is made to desired level by excavation or by means of bore holes. To make an excavation, the soil is removed by digging with pickaxe or spade. Soil is then collected in a canvas cloth or a basket. Samples by this method can be collected economically up to a depth of 6 meters. Disturbed sample may either be individual or composite type. An individual sample is one in which soil is obtained from a single layer at the same depth. To obtain composite sample, soil is trenched down the vertical face of the pit from different layers. Auger boring is the simplest method of sampling. Different types of augers are used for different soil types and depths. A hand-operated post-hole auger having sharp blades at the bottom can be used for exploration up to 6 to 7 meters. The spiral type auger is made up of a helical blade secured to a solid center shaft. Spiral auger without a center shaft is known as corkscrew. To obtain sample by auger boring, the surface is cleared of the vegetation. Auger is then placed vertically on the cleaned surface. It is then advanced into the soil by rotating and pushing downwards. When it has penetrated through its length, it is then pulled out. The soil retained in it is removed for inspection and is deposited nearby. Auger is inserted in the hole again and the process is repeated until the bore hole up to desired depth is made. The soil removed from the auger in each lift is deposited in individual stockpiles in an orderly sequence. The information so obtained may be used to plot borehole log. Augers operate best in loose, moderately cohesive moist soils. In dry soils, water is added for easy advancement of auger. Hand-operated augers are used exclusively for roadway, airport, and small structure investigations for 2 to 5 meter depths. For depths greater than 5 meters or stiff soils, mechanically operated augers are used to drill the hole. With simple and careful excavation, highly undisturbed hand-cut soil samples may be obtained. For this purpose, a pit about 1 to 2 meters in length and breadth is excavated to the desired depth. When the excavation is complete, the surface is leveled. The inner dimensions of the wooden box in which the sample has to be secured are measured. Such a box usually has equal length and breadth. A 30 cm size is quite convenient for this purpose. The inner dimensions of the box are then outlined on the excavated surface. The soil is then removed carefully around the marked area. The soil is excavated up to a depth slightly lesser than the height of the wooden box. The sides of the sample are smoothened vertically. The sample is now separated from the parent surface. A polythene sheet is spread inside the box to enclose the sample in order to avoid loss of moisture. The box is then inverted upon the sample and lifted up carefully, giving support from the bottom. The information regarding depth, place and date etc. is placed along with the sample. It is then transported to the laboratory. The sample obtained in this manner is disturbed to minimum possible degree. This method can be applied to obtain undisturbed samples for soils like clays and silts in which excavated vertical surface do not require any side support for retention. Samples 15 to 20 centimeters in diameter and 15 to 30 centimeters long are frequently obtained using metallic cylindrical samplers. The samplers employed to obtain tube samples are classified as thick-walled and thin-walled samplers. Thick-walled samplers are those having area ratio greater than 10 to 25%. An open drive sampler is one such sampler. It consists of a tube open at the lower end and attached to a head at the other end. The sampler is driven by hammering it from the top. The sampler head is provided with a valve to permit water and air to escape during driving. Sometimes the tube is split longitudinally in two parts. Such sampler is known as split spoon sampler. These two parts are held together by cutting shoe at the lower end and a coupling at the top which connects the sampler to the drill rod. The sample obtained by such a sampler can be easily examined. Such samples are of disturbed type. Some other types of samplers used for undisturbed sampling are Shelby tube sampler, piston sampler and Denison sampler. Thin-walled samplers with small area ratio are used for procuring undisturbed samples. Relatively undisturbed samples can be obtained with core cutter. The core cutter with dolly is placed with beveled edge on the cleared surface. The cutter is embedded into soil manually. Further advancement is done by giving gentle blows with the hammer. To extract the cutter, soil surrounding it is then removed. The cutter is lifted up, supporting it from the bottom. Methods explained so far like auger boring, tube sampling, pit sampling, etc. are used for shallow or moderate depths. These are suitable for design of isolated footings, combined footing and raft foundation of smaller dimensions. However, for well foundations, pile foundations or foundations of heavily loaded structures, it may be required to explore or sample at deeper depths. This calls for use of sampling techniques such as deep boring, drilling, etc., which will be dealt with in next film on soil sampling.